So the first method of solving a system of equations, so two lines, is graphing. But there's some really huge challenges that come along with that. Sometimes it's difficult to read the exact coordinates. Like, what if the answer was 1.8? You're never going to be able to read that off a graph. So we need another method to solve a system of equations. So objective 3 is method number 2 of 3. So this is solving systems of equations or linear systems by substitution. Now, I use this method when at least one of the variables in one of the equations has a coefficient of 1. So if I had this system, 5x minus 3y is equal to -6, this is my first equation, and I had another equation, which was x plus y equals 2, I'd want to look at this and say, is there a variable that has a coefficient of 1? So this has a coefficient of 5, this y has a coefficient of 3, so neither of those would I solve for. And the reason I don't want to solve for them is if I chose to solve for x, eventually I'm going to have to divide these numbers by 5, and none of them go nicely, so I'd be dealing with a ton of fractions. So it's not that you can't, it's just not easy, so we tend not to. Then in this equation, both of these variables have coefficients of 1, so you could choose either of them to solve for. So step number 1 in solving a linear system by substitution is to solve one of the equations for a variable. If one of the equations has a variable with a coefficient of 1 or -1, choose it. So if I looked at this equation number 2, so I'm taking equation number 2, and I could solve it for either x or y. For some reason, we did this equation and decided to solve for x, but I could have solved for the y as well. So I get x equals 2 minus y. Then here's the trick. I've solved equation number 2 for x. So now step number 2 is to substitute for that variable in the other equation. So since I solved equation number 2 for x, I'm going to take it and I'm going to substitute it in for x in equation number 1. Because we're dealing with an equality statement, we're saying we're looking for the point x, y that satisfies both of these lines. So if I say that in one of the lines x is this, 2 minus y, then I can say that in the other line x is that, because they should be the same x value. So here we go. I'm taking the equation 5x minus 3y equals -6, and I'm substituting in for the x. I'm putting in 2 minus y. And then what you'll notice, this is a really nice connection, is that once you take your system of equations and you substitute in for one of the variables, you're left with a linear equation in one variable. So step number 1, I simplify. So I do 5 times 2 is 10, 5 times -y is 5y, minus 3y equals -6. Then I collect like terms. I do -5y minus 3y is -8y. Then I isolate the y by subtracting 10 from both sides. And I'm left with -8y equals -16. Then I divide each side by -8, and I'm left with y equals 2. That means that for both of these equations up here, y is 2. So I can take that 2 and I can substitute it into either equation to solve for y. So this is taking a huge leap, is I substituted into the equation I already solved for x because it would be an easy way to solve for x because I could just plug in for y, but I could plug into any of the equations and I could plug them into the original and I could plug it into anything where I've rearranged because they're all the same. So I took in the 2 and I solved for x and I got x is 0. But again, you could have plugged into this equation and you'll get the exact same thing. So if I plugged in y is 2, and then I get 5x minus 6 equals -6. Then I add 6, I add 6. I get 5x equals 0. Then I divide by 5. I get x equals 0. It didn't matter which equation I substitute in for because that is the value of y in both of them. So, I don't know if I've been saying my steps all the way along. So step 1 was choose one of the equations and solve for a variable. Step number 2 was to substitute that variable into the other equation. That is the key word here, other equation. Step number 3, solve the equation from step number 2. So once you've put it in one variable, you can solve it. Step number 4, find the other value by substituting in from your answer from step 3. And then step 5 is optional. You check both equations. So my equations were 5x minus 3y equals -6. And, I mean, I would change this if I could go back into the notes and change this. I would have done it as the original question. Don't ever substitute into something that you've changed. This is silly. I can't believe that happened. I would substitute into x plus y equals 2. Always substitute into the way the equation was originally written, because if you messed up between step 1 and step 2, that might be the source of all your problems. So always sub into the original equation. So this should be 0 plus 2. Does that equal 2? Yes, it does. So since it satisfied both equations, then 0, 2 is the solution set for that system. Okay, so sometimes it's nice to see one fully worked out. Sometimes it's nice to start one from scratch. So here we go. I'm telling you that you have to solve this system by substitution. I'm going to take an equation, and I'm going to look at both my equations actually, and I'm going to look for the one that has a variable with a coefficient of 1. So here's my equation. I'm going to take this one, and I'm going to solve for y. When you solve for y, you've got 4x plus y equals 5. So I'm going to minus 4x minus 4x. I'm going to go y equals -4x plus 5. Now you're going to take that y equals -4x plus 5, and you're going to substitute it into the other equation. So sub into other equation. Okay, so I get 2x minus 3. I'm going to substitute in for y equals 13. I'm going to substitute in for y the -4x plus 5. You'll know you've done it right if you substitute a into the other equation, and b, now I should only have one variable. So now I'm going to solve this equation in one variable. So I'm going to multiply the -3 through. I'm going to distribute -3. I get plus 12x minus 15 is equal to 13. Then I'm going to collect like terms. And 14x minus 15 equals 13. Then I'm going to add 15 to both sides. I can see right away that I'm doing a good job because it equals 28. And then look at that. I can divide both sides by 14. I get x equals 2. So now 2 is the x value of my solution. I want to find my y value. So now what you're going to do is sub x equals 2 into one of your two equations, either 1 or 2. I'm going to plug it into equation 1 just for fun because it looks easier. So I've got 4x plus y is equal to 5. And again, I could have substituted into my rearranged equation if I trust myself. That's an awesome way to go. I'm just trying to simplify things, so always go back and plug it into one of your original equations, but it doesn't matter. So I'm going to substitute into, I get 8 plus y equals 5. And then I'm going to subtract 8, I get y equals -3. So I'm hoping that my solution set is 2, -3. To know for sure, I could check. So I'm going to go 4 times 2 plus -3, does that equal 5? 8 minus 3 is 5, that one's good. I could check into the other one. 2x minus 3y equals 13. 2 times 2 minus 3 times -3, does that equal 13? I get 4 plus 9, which is 13. So yes, my solution is 2, -3. All right. Here's another one. Good chance to pause your video and give this one a go. If you're back or if you just aren't ready to let go yet, you're looking at solving this system using substitution. So you're looking for the variable that has a coefficient of 1. That would be this x. So I'm going to take this equation and I'm going to solve for x. So I'm going to subtract 2y, subtract 2y. I get x equals -2y plus 2. Then you're going to take that x and you're going to substitute it into the other equation. If you substitute it into itself, what's going to happen is you're going to get an identity. It's going to end up that the x term goes away. So make sure you're substituting into the other equation, because otherwise, if you substitute into yourself, there's an infinite number of solutions because everything on that line is on the other line as well, okay? Or on that same line. So I'm going to plug in for x. I get 2 times -2y plus 2 minus 3y equal to 18. I'm going to distribute through. I get negative 4y plus 4 minus 3y equals 18. I'm going to collect like terms. Negative 7y plus 4 equals 18. I'm going to subtract 4 from each side. I get negative 7y. I start getting this excited feeling when I get a number that the 7 will go into. So now I'm going to divide by 7, negative 7, and I get y equals negative 2. They don't always turn out nice. Like if you get a fraction, you're not necessarily wrong, but most of them come out as nice numbers. So now that I've got y equals negative 2, I need to take this negative 2 and substitute it in for y in one of these two equations, or into this equation, depending on how confident you feel with your rearrangement. I mean, this one would be ideal. So let's do that this time. I'm going to plug it into that second equation in its rearranged form. So I'm going to plug in y is negative 2. I get 4 plus 2 is 6. So I'm guessing that my solution is 6, negative 2. Be careful. The first one you solve for is not always x, so make sure you put it in the right spot in your ordered pair. So now I'm going to check. I've got 2x minus 3y equals 18. I've got 2 times 6 minus 3 times negative 2. That's 12 plus 6, which is 18. Awesome. And then my other one is x plus 2y equal to 2. I've got 6 plus 2 times negative 2. Does that equal 2? That's 6 minus 4, and I'm good. So my solution set would be the point 6, negative 2. So this is the point, and the only point, that satisfies both equations. It's the point on the graph where those two lines cross. All right, go and practice solving by substitution.